could you secure AI agents and models against misuse while still meeting governance, compliance, and responsible AI requirements? Hi and welcome. I'm Georgia, lead technical trainer at Microsoft, and in this session, we will cover how to keep your agents secure and well-governed, from protecting models and handling prompt-based risks to staying aligned with responsible AI practices. Let's get started. By the end of this video, you'll be able to design AI systems that balance innovation with accountability, apply identity and access controls to secure AI agents, implement observability and threat protection, translate compliance requirements into technical controls, and how to mitigate vulnerabilities across prompts, models, and workflows. Let's start with agent security, the foundation for any agentic AI architects. AI agents are not just software, they make autonomous decisions with real data and real users. That means real security risks. Every agent, tool, and pipeline needs its own unique identity. Without it, you cannot audit or enforce access controls. Assign a unique cloud identity per agent in every environment. Track ownership, version, and lifecycle metadata. And always prefer managed identities for authentication. They eliminate embedded secrets and simplify credential management. Authorization determines what agents can actually do. The golden rule is least privilege at the narrowest scope. Two patterns matter most. When an agent acts for a user, it inherits that user's permissions, never exceeds them. When acting autonomously, it gets a dedicated role with only the actions it needs. This prevents privilege escalation and limits the blast radius of any compromise. Separation of duties ensures no single role has too much control. Define distinct roles. Makers build agents, publishers release them. Environment admins manage infrastructure, and security admins enforce policy. No one should build, approve, and deploy without oversight. Require formal approvals for production publishing, especially for high-risk capabilities. This creates the checks and balances that keep your AI ecosystem safe. Agents must use only the right data in the right places for the right duration. Separate internal from public-facing workloads. Confidential data should never reach external-facing agents. Honor data residency requirements when choosing where to store knowledge, logs, and agent memory. This is about building trust by showing your AI respects data boundaries by design. DLP policies restrict what connectors agents can use and how data moves through your system. Complement them with sensitivity labels on knowledge sources. When an agent pulls from multiple sources, it should surface the highest classification in its response. Together, DLP and labels form practical guardrails that protect data without blocking legitimate agent activity. Make sure you define clear retention windows for logs, memory, and training data, then automate the cleanup. Manual processes will not scale. On the transparency side, tell users when they are interacting with AI, explain how the data is used, and give them clear ways to request deletion. This is both an ethical best practice and increasingly a regulatory requirement worldwide. This diagram maps how data flows through your agent ecosystem. Sources on the left feed the agent runtime, which sends data to observability sinks and archives. Every node should be annotated with its region, sensitivity labels, DLP posture, and retention policy. Mapping these flows gives you visibility into where data lives, how it moves, and whether it meets your governance requirements. Observability lets you see what your agents are actually doing. Make sure you centralize all telemetry, prompts, tool calls, error, and safety events into a single workspace. Beyond technical metrics, capture business metrics like task completion and escalation rates. These tell if your agents deliver real value. Designing observability from the beginning is one of the highest impact decisions you can make. Now let's talk about keeping track of your agents and their costs. Inventory management means maintaining authoritative catalog of every agent, owner, version, environment, and purpose. On costs, tag every resource by agent and cost center, then track token consumption closely. Set alerts for spend spikes. A sudden jump could signal a runaway agent, a prompt injection, or an inefficient workflow. Cost governance doubles as an early warning system for security issues. Now we shift from monitoring to active defense. You need protections that detect prompt manipulation, data leakage, and risky outputs in real time. Two strategies work together. AI-aware threat detection that understands language model attack patterns and input-output filtering that sanitizes what goes in and moderates what comes out. Think of it as a security perimeter designed for how AI processes information. Make sure you red team your agents before production and after every major change. Gate releases on closure of critical findings. For incidents, define how to disable an agent, preserve logs, notify stakeholders, and recover safely. And here's what many teams miss. Rehearse your response plans through tabletop exercises. When a real incident hits, your team should already know the playbook. Standardizing how agents connect to tools, data, and each other is essential for scalable governance. Make sure you adopt a standard agent framework with built-in governance hooks and clear documentation. For protocols, use Model Context Protocol or MCP. For structured tool and data access and agent-to-agent. For controlled delegation and context sharing between agents. Provide safe development environments through environment routing, keeping dev and test cleanly separated from production. Finally, enforce change control by versioning all artifacts, requiring approvals, and running automated security checks before any agent gets published. These standards create a predictable, auditable development lifecycle. Here's your 6-step action plan. Establish identities and access with managed identities. Harden data access with DLP and residency controls. Set up centralized observability. Enable threat protection and red team assessments. Govern environments with peer review and automated checks. And prepare incident response with documented procedures and rehearsals. Work through these sequentially for a robust security foundation. Now let's move on to design governance for agents. These are the practices that keep your agents accountable and well managed throughout their lifecycle. Every agent needs a named owner responsible for its lifecycle and security. Maintain a registry documenting each agent's purpose, environment, risk level, and data access. For sensitive agents, require publishing approvals. When something goes wrong, you need to immediately know who owns it and who approved its deployment. Clear ownership makes everything else in governance possible. Agents must operate with secure, isolated identities. There are 3 key practices here. Make sure you use managed identities instead of embedded secrets. Assign least privileged permissions, scoped by environment, and segment roles clearly. Makers build, approvers validate, admins manage, and security enforces. Each role gets only what it needs, ensuring no one can bypass governance controls. Data governance defines what agents can access, store, and generate. Enforce classification across all sources, restrict agents to approved data, apply DLP policies on connectors, and honor residency rules. Make sure you also use sensitivity labels through the pipeline. This layered approach from source classification through runtime controls to output labeling creates a framework where each layer reinforces the others. Centralized monitoring gives you visibility into what your agents are actually doing, and that visibility is essential for audit and operational trust. Log everything meaningful, including prompts, actions, outcomes, errors, and escalations. You can build dashboards that show success rates, failure patterns, and unexpected behaviors at a glance. And you can set up alerts for anomalous activity like rapid token spikes or unusual data access patterns, which could signal a compromised agent or a prompt injection attack. On the cost side, tag every agent resource for attribution. Set usage thresholds for review consumption patterns regularly. Monitoring is not just about finding problems, it is about building confidence that your agents are operating as intended. Security must be active throughout an agent's entire lifecycle, not just at deployment. Make sure you enforce runtime protection, apply input-output filtering against injection and leakage, and integrate agents into your existing security operations. Same alerts, same playbooks. Agents should never exist in a security silo. Full integration gives your security team complete visibility into AI-specific threats. When agents interact with external APIs, only allow approved connectors and endpoints. Validate every authentication method and scope, and agents should use minimum credentials. Ensure external data flows comply with your policies and contractual obligations. Your vendor contracts may restrict what data you share through automated systems, so make sure you map these obligations to technical controls before enabling any external integration. Governance works best when development is predictable. Use standard templates for agent creation and documentation. You should make sure you version control prompts, knowledge sources, and workflows, not just the code. Before production, run mandatory pre-published checks on security posture, DLP, and data access. These automated gates catch issues before they become incidents. Agents evolve, and your governance must keep pace. Make sure you schedule regular reviews for accuracy, data freshness, and risk changes. A low-risk agent at launch might become high risk as its access expands. Define criteria for retiring unused agents, since dormant agents with active credentials are a security liability. Treat production agents with the same deployment rigor as any production software. Let's move to a very important topic, model security. While previous sections focused on agents and governance, this zooms in on securing the AI models themselves. Securing model identities follows the same principle as agents, but with additional rigor. Secure model identities with managed identities for every endpoint and workload. Make sure you eliminate all secrets and static keys from your pipelines and enforce identity lifecycle management with rotation and regular review. For access control, apply the least privilege strictly. Separate the training permissions from deployment and inference. This ensures compromising one role does not expose the entire model lifecycle. As an agentic AI architect, defining access boundaries around models is a core architect responsibility. Segregate development, test, and production endpoints completely. Restrict the ability to modify, retrain, or redeploy models to a small set of authorized roles with multi-step approvals. You can use 3 layers of control: identity boundaries outside, model execution in the middle, and data boundaries at the core. Each must hold independently. Models interact with sensitive information at multiple points through training data, memory stores, logs, and output responses. Your job is to protect data at every stage. Practice data minimization by using only what the model actually needs. Redact sensitive fields like PII, secrets, and financial identifiers during pre-processing, not after. Ensure all data is encrypted at rest and in transit, including intermediate artifacts that are easy to forget. Deploy the models in regions that meet your residency and compliance requirements and apply DLP rules to prevent sensitive data from appearing in model responses. This approach from input to processing to output closes the data protection loop around your models. Hardening AI workloads means reducing the attack surface of the environment where your models operate. Use isolated networks or private endpoints to prevent unauthorized access. Enforce secure build pipelines for training artifacts so that no tampered code or data enters your training process. Make sure you block inbound public traffic unless you have a specific documented requirement for it. Then you can address model drift and data poisoning. Track data lineage for every training source. Make sure you validate any newly introduced data before using it in retraining pipelines and automate anomaly detection in model behavior and output patterns. A subtle shift in model outputs could indicate poisoning. Catch it early through continuous monitoring. Threat detection and response for models requires AI-specific capabilities. Enable detection that understands prompt injection attempts, unauthorized access patterns, and unusual inference behavior. Use automated scanning to find insecure defaults and misconfigurations before attackers do. For logging, collect everything relevant, including identity access events, model operations, system events, and output anomalies. Route security alerts directly to your SOC workflows for triage and escalation, and predefine your incident response steps. Know exactly how to disable a compromised model endpoints, preserve inference logs for forensics, and roll back to a known good model version. Rehearse these steps regularly because speed matters when a model is compromised. Governance ensures models stay secure across their entire lifecycle. So make sure you have approval checkpoints at deployment, retraining, and version promotion. You should also require documentation on purpose, training data, parameters, and risk profile. Set retention requirements and regularly review deployed models. Retire those that no longer meet standards. Security is not a one-time thing, it's a continuous cycle. Let's discuss how to analyze solution and AI vulnerabilities and mitigations, including prompt manipulation. Prompt manipulation steers models away from intended behavior. Attackers override system instructions, create deceptive context, use multi-step coercion, and embed hidden instructions in files. The impacts include data exposure, unintended actions, harmful hallucinations, and compromised automations. Make sure you design your defenses, assuming prompt manipulation will be attempted, because it will. Beyond prompt attacks, models have inherent vulnerabilities. They hallucinate convincing but false information. They may produce harmful content, and they can have weak safety boundaries. Bias leads to unfair results and overgeneralization, creating compliance risks. So make sure you continuously evaluate the output, safety, correctness, consistency, the response variability, and drift after retraining. This regular evaluation is your early warning system. AI systems often access sensitive data, making data exposure a critical risk. Prompts can indirectly reveal confidential information. Logs and even memory may store unprotected data, and excessive permissions let models access more than they need. Input files can carry hidden instructions that trick models into leaking information. The fix? Data minimization. Strict role-based access control and intent-based access aligned with user roles. Weak identity configuration gives attackers a foothold. Without a proper control, they can interact with models using elevated privileges and escalate through misconfigured connectors. Make sure you enforce least privilege, use managed identities everywhere, segment environments so development cannot reach production, and review access logs for anomalous elevation attempts. Identity gaps are among the most common and most preventable AI vulnerabilities. When agents automate tasks, they introduce workflow-level risks. Autonomous tool use without guardrails causes unintended consequences. Poor auditing makes it impossible to trace what went wrong, and unsecured third-party calls create exfiltration paths. Ensure agents work within defined tool boundaries, enable end-to-end auditing, and test complete workflows, not just individual actions before production. Monitoring is your front line for detecting prompt attacks and unusual behavior in real time. Make sure you cover 4 areas. Watch AI logs for anomalies, investigate spikes in harmful output, track risk indicators on dashboards, and capture the full chain of prompts, tool calls, and actions. Correlating these events reveals sophisticated attacks that look normal at any single step. Structured evaluation pipelines are non-negotiable. Make sure you test these four things. Prompt resilience. Can the model resist manipulation? Safety behavior. Does it refuse dangerous requests? Version impact. How do outputs change after retraining? And abnormal response detection. Can you catch issues before users see them? Run these questions before every release and regularly after, because models drift over time. Strict identity and role-based access controls are among the most effective mitigations. Least privilege for every agent, model, and pipeline. Manage identities everywhere. Data access restricted to exactly what is needed. Use approval workflows for privileged operations. These basics are surprisingly often overlooked when teams rush to deploy AI. Hold the line, they prevent the majority of access-based vulnerabilities. Input and output filtering forms your next critical defense layer. Input filtering blocks code execution attempts and strips unsafe HTML or embedded prompts. Output filtering catches harmful or policy-violating content before users see it. Limit accepted file types, because every format is a potential attack vector. No single filter catches everything, but together they dramatically reduce the surface for both prompt manipulation and data exfiltration. So, as we said, no single control is enough. You need layered defense. 5 layers here work together. Identity and access boundaries, secure data governance, model evaluation and testing, monitoring and anomaly detection, and incident response readiness. Each compensates for gaps in the others, so ensure all 5 are implemented, none are optional. So let's dive into reviewing solutions for adherence to responsible AI principles. Responsible AI is foundational for every agentic AI architect. It ensures your systems are safe, compliant, transparent, and aligned with real-world expectations. What makes it powerful is the structured, repeatable method you can apply across governance, risk, design, deployment, and operation. It is not a one-time checklist, it is a continuous practice built into how you architect solutions. There are 6 core principles that guide every design decision. Fairness ensures equitable treatment. Reliability and safety keep systems functioning safely. Privacy and security protect data. Inclusiveness empowers all users. Transparency makes systems understandable. And accountability keeps organizations responsible. Assess every model, agent, and workflow against all 6. They are interconnected and none should be sacrificed for another. Start your responsible AI review by evaluating purpose and intended use. Assess 4 dimensions: business justification, user personas, and expected actions, the data used for reasoning and training, and boundaries communicated to users. If the intended use is unclear or misaligned with policy, no amount of technical controls will make the solution responsible. This is your foundation. The data, privacy, and security assessment validates whether your solution respects data expectations at every level. You need to evaluate 5 areas. First, sensitivity classification of all data sources, ensuring you know exactly what you are working with. Next, data minimization, confirming the solution uses only the data it genuinely requires. Third, retention and storage expectations, so data does not persist longer than necessary. Fourth, protection of personally identifiable information through appropriate technical controls. And last, isolation of confidential data combined with least privileged access. This assessment matrix maps controls across data sources and access levels, giving you a systematic way to verify coverage rather than relying on assumptions. Evaluating model and agent behavior through structured tasks is how you move from trusting AI to verifying it. You should test 5 specific areas. First, start by identifying hallucination patterns where the model generates confident but incorrect information. Then validate instruction and prompt adherence, ensuring the model follows its system prompts reliably. Next, assess safety boundaries in edge cases because that is where models most often fail. Then confirm fallback behavior for unknown or ambiguous requests, so the model fails gracefully. And finally, verify the model does not produce harmful or misleading content under any conditions. This behavior risk radar visualizes these dimensions, helping you identify which areas need the most attention for your specific solution. Fairness and bias review addresses whether your AI solution treats all user groups equally. Look at potential different impacts: training data representativeness, mitigation strategies for detected bias, and fairness testing with both synthetic and real-world data. Build fairness testing into your evaluation pipeline as a standard gate, not as an afterthought. Users must know they are interacting with AI, understand its limitations, and have clear paths when things go wrong. So make sure AI involvement is communicated, the capabilities are clear, documentation and escalation paths are accessible, and feedback drives improvement. Transparency empowers users to decide when to trust the outputs and when to verify. That is the hallmark of responsible deployment. You don't need to build responsible AI capabilities from scratch. Leverage the existing validation checks, bias detection tooling, model lineage documentation, and governance processes for review and sign-off. Document everything. Documentation makes your responsible AI practices auditable and repeatable across your organization. Responsible AI requires continuous oversight. 4 elements make it work: an AI-specific incident response plan, regular evaluation of logs and model drift, governance board reviews for major updates, and clear sunset criteria for underperforming models. Sometimes retirement is the right call. This life cycle approach ensures your commitment extends from design through production. So let's now discuss how to validate data residency and movement compliance, focusing on ensuring AI solutions comply with geographic and regulatory data boundaries. Data residency defines the physical or geographic location where customer data is stored and processed. This sounds simple, but AI solutions yield multiple services and tool chains that complicate it significantly. You must understand where user prompts, context, and model inputs are processed, which services store your logs, your conversations, and telemetry, and whether data used by generative AI stays within its designated region, and how multi-tenant cloud services distribute their workloads. Map your data residency boundaries explicitly, covering input regions, processing regions, storage and logging regions, and backup or disaster recovery regions. Without this map, you cannot verify compliance, and you certainly cannot prove it to auditors. Copilot Studio enforces regional boundaries, but agentic AI architects must validate the details. Check where prompt data is actually processed. Verify unpublished agents and whether they follow the same residency rules. Examine how connectors may introduce unexpected data movement and investigate cross-region interactions during inference. These checks are critical where data crossing a border triggers compliance obligations. Generative AI may move data for evaluation or orchestration, and these need strict controls. Identify components that transmit data outside the designated region. Confirm whether that movement is necessary. Review settings restricting cross-geographic operations, and apply policies blocking cross-region routing for sensitive workloads. Do not assume your configuration is correct. Verify with actual data flow testing. Purview is your enforcement layer for data compliance. Apply sensitivity labels, creating hard boundaries on data transmission. Use DLP rules to block sensitive data in prompts and outputs. And make sure you review auditing and compliance documentation. Validate that interaction logs follow residency rules. Purview turns residency policies from aspirations into verifiable technical controls. So let's move on to designing access controls on grounding data and model tuning. Grounding data makes model responses accurate, so Access must be carefully controlled. There are 4 design principles that are important to remember: least privilege by default, role-aligned data partitions, clear ownership with accountable stakeholders, and full auditability, where every access event is logged. These ensure grounding data stays accessible to those who need it while protected from misuse. The recommended architecture for grounding data access starts with authenticating the user or the agent's identity through role-based access control, or managed identities. That identity then accesses grounding data gateway, which enforces access boundaries across different data partitions. Think of the gateway as a policy enforcement point. It sits between your consumers, whether human users or AI agents, and your data partitions for finance, HR, product, and documentation. Each partition has its own access rules aligned with roles and responsibilities. This architecture ensures that a customer support agent cannot access finance data, and an HR model cannot reach product engineering information. The gateway model gives you centralized control with distributed data access. AI systems retrieve grounding data during search, retrieval augmented generation or RAG, or context assembly. Each retrieval mechanism must enforce when AI systems retrieve grounding data through search, retrieval augmented generation, or context assembly. Each retrieval mechanism must enforce strict controls. There are 4 specific requirements that apply. Connected level authorization restricts which data types the model can query. Structured query filtering prevents models from accessing disallowed fields within a data source. DLP and sensitivity labeling must be applied across all data stores, not just the primary ones. And region-aligned access rules ensure data residency compliance even during retrieval. Follow this flow, from prompt to policy check, to search index, to sanitization layer, to model context injection. At every step, governance is enforced. Never assume retrieval is safe by default. Model tuning operations require elevated permissions and must be carefully insulated from production. Whether you are running evaluation, supervised fine-tuning, or reinforcement learning, 5 controls are essential. Segregate environments completely, with separate infrastructure for development, evaluation, and production. Require approval workflows before introducing any new training datasets. Make sure you verify data lineage and maintain documentation for every tuning dataset. And apply security scanning to all tuning inputs, because poisoned training data is a real threat vector. Make sure you also restrict the ability to promote tuned models to production, require explicit sign-off. These controls ensure that model tuning, which directly shapes model behavior, cannot be subverted or rushed without proper oversight. Guardrails prevent unsafe data from influencing model behavior. Implement block lists for prohibited document types. Build sanitization pipelines that strip PII automatically, and run safety reviews on every data input. Make sure you also deploy alerting for unusual access patterns. The sequence: raw data enters, validation applies, sanitization removes risks, then data becomes approved, so no exceptions. Continuous monitoring ensures your access controls actually work as intended in production. 4 operational controls are essential. Log all prompt activity, tuning actions, and retrieval-based access events. Periodically review role-based access control assignments to catch permission drift, where roles gradually accumulate more access than they need. Make sure you deploy automated anomaly alerts that flag abnormal retrieval patterns, which could indicate unauthorized access or data exfiltration attempts. And maintain governance dashboards that track how grounding data is being used across your organization. Monitoring is what transforms your access control design from a static policy document into a living enforced system. Without it, even well-designed controls can degrade over time. And before we wrap up, let's discuss how to design audit trails for changes to models and data. Let me explain why audit trails matter so much in AI systems specifically. They help organizations track changes to model versions, parameters, training datasets, and evaluation results, giving you a complete history of your model's evolution. They enable diagnosis of issues, anomalies, and regressions when model behavior changes unexpectedly. They meet regulatory expectations around transparency and accountability, which are growing more stringent globally. They support investigations during incident and security reviews with concrete evidence, and they strengthen operational governance by enabling approvals, rollbacks, and lifecycle controls. A well-designed audit system has three essential properties. It is continuous, it is immutable, and is integrated into the AI platform's control plane. Model lifecycle events that must be audited span the entire journey from creation to retirement. Registration of new model versions, tuning operations, including fine-tuning and evaluation runs, the promotion between environments, rollbacks, deployment actions, and every access attempt, including unauthorized requests. For your architecture, ensure logs are immutable, so they cannot be tampered with, that they're timestamped for accurate sequencing and linked to identities through your identity provider. It's good if they're structured in JSON format for machine parsing and capture separation of duties and approval workflows. These audit requirements are not optional. They are fundamental to demonstrating governance and meeting compliance obligations for AI systems, especially in regulated industries. Changes to grounding data, training data, memory stores, and indexes all must be audited. Capture ingestion events, schema changes, refresh cycles, label changes, sanitization steps, and cross-region movement. There's one critical principle. Logs capture metadata, not content. Record who accessed what and when, but never replicate the sensitive data itself. Audit for accountability without creating new exposure risks. Microsoft Foundry provides a centralized control plane for model registration, environment configuration, agent deployment, and diagnostic logging. There are two key features that stand out. The Foundry activity logs track all administrative actions across workspaces, registers, and deployments. These can be exported to Azure Monitor, Log Analytics, and CM tools like Sentinel. Foundry diagnostics and tracing provide execution-level traceability across model, calls, pipeline activities, tool interactions, and failures or latency spikes. Together, these features give you both the high-level governance view and the detailed technical view you need. Configure these exports from day one, not after an incident forces you to set them up retrospectively. Notice the flow from the control plane through monitoring tools to dashboards and review processes. The key design decision is bidirectional visibility. Dashboards surface both routine and security events, and reviews drill down from alerts to specific log entries. Design this as an integrated pipeline, not disconnected endpoints. Tracing lets you follow execution paths at a granular level. It provides end-to-end inference visibility, bottleneck identification, version attribution, correlation of user actions to model activity, and detection of unusual patterns like loops or token spikes. Tracing transforms your audit trail from a passive record into an active diagnostic and investigation tool. Effective tracing requires the right fields: correlation IDs linking events across systems, model version identifiers, non-sensitive input metadata, prompt categories, response latency, downstream tool usage, and safety evaluation outcomes. These give you comprehensive traceability without exposing sensitive user data. Designing audit-ready processes means building governance workflows that generate audit evidence as a natural byproduct of operations. So make sure you include approval workflows for model promotion, mandatory tuning logs, periodic drift detection, automated compliance collection, and immutable storage. For retention, 90 days for low risk, up to 24 months for regulated workloads, and indefinite for incident archives. This diagram illustrates the flow of change events from users and developers through AI model and data systems into the audit and trace layer. The audit data is then exported to monitoring and compliance platforms, supporting dashboards, alerts, and governance teams for review and compliance. So let's review everything we have covered in this video. You have learned how to design AI systems that balance innovation with accountability, ensuring that advancing AI capabilities does not compromise trust. You can now apply identity, access control, and data governance to secure AI agents using managed identities, list privilege, and layered defenses. You now understand how to implement observability and threat protection, building monitoring and response capabilities into your architecture from the start. And you can translate compliance requirements into technical controls for data residency, retention, and audit trails. Finally, you can mitigate vulnerabilities across prompts, models, and workflows using defense in-depth strategies. Take these practices forward as you build the next generation of responsible, secure, and governed AI solutions. We've covered a lot in this session, and there are many ways to continue your learning journey. Keep the momentum going by exploring the rest of the videos in this course or discovering your next favorite topic on Microsoft Learn at aka.ms/learn. Thank you for watching. You are now ready to leap the shift towards intelligent and secure business solutions.